Stop everything. I'm your trusted monkey, and today I'm bringing you 40 lies that got drilled into your head about history and science. Lies you've been carrying around since grade school. We're going to cover Romans who didn't eat what you think, a planet that doesn't spin the way you were told, gold that was born incredibly far away, calendars missing days, and a compass that's lying straight to your face. It's not your fault, everyone got taught the same things, with the same confidence they used to teach you to tie your shoes. So stick around, because in the next few minutes, I'm going to make you say, no way, I believed that my whole life, a whole bunch of times. Subscribe now, because we're diving in full speed, and you won't want to miss a single one. You're sitting in your chair, you rest your hand on the table, and you swear you're touching it. Almost a lie. At the atomic scale, you and the table never actually touch. An atom is almost entirely empty space. If you blew up an atom to the size of a football stadium, the nucleus would be barely a pea sitting in the middle of the field, and everything else would be empty space. When you touch something, what's really happening is that the electron clouds of your atoms and the table's atoms repel each other through electromagnetic force, without ever actually colliding. That resistance you feel, that pressure of the table pushing against your hand, is pure electric repulsion working across a tiny distance. There was never any real contact between the matter. Your whole life you've been touching things without ever touching them once. You're made almost entirely of empty space, resting on something almost entirely empty, never brushing against it. Solidity is a beautiful illusion. You picture a Roman in a toga eating a plate of noodles with tomato sauce, very Italian, straight from Nonna's kitchen. False. Completely false. The tomato is American, a plant that grew on this side of the world, and it didn't cross over to Europe until after 1492. Julius Caesar never saw a tomato in his life, not even in a painting, and red sauce took centuries longer to work its way into Italian cooking, because at first Europeans looked at the tomato with suspicion and kept it as decoration. Dry pasta, as you know, it became popular much later, largely thanks to the Arabs in Sicily. In other words, the classic and ancient image of Italian food is newer than a lot of people's last names. A human ate bread, olives, legumes, and garum, a fermented fish sauce with a smell that would knock you over. The Italian cuisine you're picturing isn't ancient, it's an invention younger than you think. You were taught that metals are hard, cold, and solid, and that melting one requires a forge or a brutally hot furnace. Only half true. There's a metal, gallium, that melts from the heat of your own hand. It looks like a solid silvery metal, similar to aluminum, but its melting point is only about 86 degrees Fahrenheit, lower than your body temperature. If you grab a small piece and hold it in your palm, within a few minutes, it starts dripping between your fingers like butter in the sun, turning into a little puddle of shiny liquid metal. Then it solidifies again once it cools down, no problem. It's not toxic to the touch like mercury, so it gets used a lot for experiments and demonstrations. It's one of those things that looks like magic, but is textbook chemistry. Not every metal needs fire. Gallium surrenders to the warmth of a hand. You grab your compass. The needle points north, and you figure, great, science solved. Backwards, literally. Your compass needle is a magnet, and with magnets, opposite poles attract. North with south. If the north tip of your needle points toward the Earth's geographic north, it's because up there sits a magnetic pole that is actually a south pole. In other words, what we call the planet's magnetic north is, in physical terms, a south pole in disguise. We gave it that name for convenience, so we wouldn't drive ourselves crazy, but the physics says otherwise. The Earth works like a giant magnet with its polarity flipped from what the name suggests. Your compass isn't lying about the direction, but the label we gave it definitely is a joke. You point north, thanks to a hidden south sitting beneath your feet on the other side of the world. You think of the Colosseum and picture sand, dust, and nothing else. Incomplete. According to several Roman authors from the period, in its early years, the Colosseum could be flooded to stage mock naval battles, with real ships floating inside. A spectacle they called a naumachia. Picture the effort. A huge stadium turned into a giant pool with a system of channels to bring water in and drain it out. Chroniclers like Cassius Dio described these water shows at the inauguration in the year 80. Later, once they built the underground chambers with cages and passageways beneath the arena floor, flooding it became impossible and the trend ended. It's a fact debated among historians, but the ancient sources describe it in detail. So what you see today as a dry ruin was for a while a theater of water. The Colosseum wasn't just dirt and sand. It started out also as an enormous Roman swimming pool. You look for pink among the colors of the rainbow, and you swear it's in there somewhere. Near the red. Backwards. Pink isn't in the rainbow. And on top of that, it has no light color of its own. Every color of the rainbow is a wavelength, a type of light. Red is one, violet is another. But pink, or magenta, doesn't correspond to any wavelength at all. It's an invention of your brain. It shows up when your eyes receive red and blue light at the same time with no green in between, and your brain, not knowing what else to do, decides to merge them into a color that physics doesn't have on its list. It's a trick, a color that only exists inside you. If you search for pink in the light spectrum, you'll never find it. No matter how hard you look, pink isn't a color found in nature. It's an idea created by your own brain. You say Emperor Julius Caesar with total confidence, like it's obvious. False. Julius Caesar was never an emperor of Rome, not for a single day. In his time, Rome was still a republic, and he did rise to become dictator with enormous powers, yes. But that title wasn't the title of emperor. The first Roman emperor in history was Augustus, his great-nephew and adopted son, who only took that power in the year 27 BC, sometime after Caesar. In other words, the man whose name gave rise to the word Caesar, for every emperor that came after, technically never held the position he inspired. It's like putting your last name on a company someone else founded. The imperial title starts with Augustus, not with him. So every time you say Emperor Julius Caesar, you're promoting a guy to a job he never actually had. You assume the calendar always ran evenly, one day after another, without a hitch. Completely false. In October of 1582, from one day to the next, 10 whole days were erased from the calendar. People went to sleep on Thursday, October 4th, and woke up on Friday, October 15th. There was no October 5th, 6th, 7th, or anything up through the 14th. Why? Because the old calendar, the Julian calendar, had a small error that added up over centuries had thrown off the dates. And Pope Gregory XIII ordered the adjustment to fix everything, creating the calendar you use today. Different countries adopted it at different times, and when England's turn came in 1752, they had to skip 11 days. Imagine losing almost 2 weeks of your life by decree, just like that, all at once. The calendar isn't a perfect, unbroken line. It has a huge hole in 1582, where 10 days are missing that officially never existed. You say pyramids, and your mind travels straight to Egypt, to Giza, to camels and the Sphinx. Incomplete. The country with the most pyramids in the world isn't Egypt, it's Sudan. Its neighbor to the south, in the region of ancient Nubia, especially around the city of Meroe. More than 200 pyramids of the Kingdom of Kush were built, while Egypt has around 130. They're smaller, thinner, with steeper walls, but pyramids all the same, and there are a lot more of them. They were built by Nubian kings and queens who ruled a powerful civilization that even went on to dominate Egypt for a period of time. The problem is that tourism and postcards took all the fame to the Egyptian side, and Sudan's pyramids got forgotten, tucked away in the desert and rarely visited. So, the pyramid capital of the world isn't where you think it is. Egypt has the fame. Sudan has the numbers. Hang on, don't leave yet, because in line number 18, I'm going to show you that something you carry in your pocket every day wouldn't work without the craziest theory in physics. Stay with me. You think gold formed peacefully inside the earth, like just another rock in the pile. Incomplete. The gold in your ring was forged in the most violent event that exists. The collision of two neutron stars, those ultra-dense stellar corpses where a single teaspoon would weigh as much as a mountain. When two of those things crash into each other, they release an explosion called a kilonova that manufactures heavy metals like gold and platinum and spits them out into space. On August 17, 2017, gravitational wave detectors picked up one of those collisions 130 million light years away and confirmed that gold gets cooked up there. And just recently, in 2025, a second factory was discovered. Flares from ultramagnetic stars called magnetars, which also spit gold out into space. Whichever recipe it came from, the gold in your ring was forged incredibly far away and arrived as cosmic dust, getting trapped here when the solar system came together. Your necklace is a souvenir from a stellar catastrophe. It didn't come peacefully out of a mine. It came out of the violence of dead stars. You were told that water either boils or freezes or stays liquid one thing at a time, and that's it. Incomplete. There's a magic point where water does all three things at once: boiling, freezing, and staying liquid, all together and in balance. It's called the triple point, and it happens at a temperature of just about 32 degrees Fahrenheit and at a very low pressure, much lower than what you get at sea level. Under those exact conditions, you see water bubbling as if it were boiling and forming ice, while liquid is still present, all three phases coexisting in the same instant. It's not a magic trick. It's pure physics, and it's so precise and reliable that for years it was used to define the temperature scale. Nature has a strange little corner where the rules you were taught break down. Water doesn't always pick just one state. At its triple point, it does all three at once. In the movies, you see everyone, all day long, wandering around in their togas, even to eat at home. A lie. The toga was formal wear, uncomfortable, heavy, impossible to put on alone. Kind of like the suit you pull out once a year for a wedding. It was worn for public events, courts and ceremonies, and it was exclusive to free male citizens. For everyday life, for work, for hanging around the house, people wore the tunic, a simple, comfortable garment, like a long sweatshirt. Putting on a toga properly was an art that required a slave's help and hours spent arranging several yards of fabric. Nobody with any sense walked around in that just to buy bread. It would be like going to the produce stand in a tuxedo. So the next time you see a crowd in togas in the background of a movie, now you know they put on their formal wear even to take a nap. You think the iciest corner of the cosmos is on some far-off planet or deep in outer space. Almost a lie. Space isn't as cold as you imagine, because it floats at around minus 455 degrees Fahrenheit due to leftover heat from the Big Bang. The coldest natural spot we know of is the Boomerang Nebula, at just over 1 degree above absolute zero, around minus 458 degrees Fahrenheit. But the all-time cold record doesn't belong to nature. It belongs to us. In labs here on Earth, physicists cool atoms down to tiny fractions of a degree above absolute zero. Temperatures of billionths of a degree that don't exist naturally anywhere else in the universe. In other words, the coldest known place in the entire cosmos is a lab bench with equipment, built by humans in lab coats. Next time you're cold, remember, not even the vacuum of space can beat the freezer we built in a laboratory. It sounds like an exaggerated legend, a general crossing snowy mountains with elephants like some kid's story. But it's true. Hannibal, the Carthaginian general, crossed the Alps in 218 BC with his army and around 37 war elephants to attack Rome from a direction nobody expected. The part that really is exaggerated is how many made it. The trek through the cold, hunger, and narrow mountain passes was so brutal that most of the elephants didn't survive the crossing, and only a very few were still standing for the battles in Italy. One famous elephant, named Surus, is said to have been among the last ones left. It was one of the boldest military maneuvers of the ancient world, real and documented. So the next time someone tells you it's a myth, correct them. The elephant part really happened. What didn't happen is that the whole herd made it to the other side. You've probably never stopped to think about it, but October has the word octo inside it, which means 8, and yet it's the 10th month. A lie hidden in the name. The answer lies in the old Roman calendar, which started in March. Not January. Count from March. September, with septi for 7, landed 7th. October, with octo, 8th. November, with nov, 9th. December, with dec for 10, 10th. Everything lined up perfectly. Later, when the start of the year moved to January, the names got shifted 2 spots, and nobody bothered to rename them. On top of that, 2 months were renamed after powerful people. Quintilis became July in honor of Julius Caesar, and Sextilis became August after Emperor Augustus. That's why today you have 4 months with the wrong number hidden in their name. The months on your calendar have had a factory error for more than 2,000 years, and nobody ever fixed it. You know the moon moves the tides. But you never stopped to ask yourself why the sea rises and falls twice a day instead of once? Good question, because the answer is really strange. The moon pulls on the water on the side of the earth facing it, and that's where a bulge forms. A high tide makes sense so far. The crazy part is that on the opposite side of the planet, the side farthest from the moon, another bulge forms at the same time, another high tide. This happens because the moon's gravity pulls harder on the nearby water, with average force on the center of the Earth, and with less force on the far water, and that difference leaves the water on the far side bulging outward. The result, 2 humps of water on opposite sides. As the Earth spins, every point along the coast passes through both humps every day. It's not one tide caused by the moon. It's 2, and one of them is on the side where you can't even see the moon. You look at the giant stones of Stonehenge and automatically picture druids in robes performing rituals. Wrong story. Construction of Stonehenge began around 5,000 years ago, and the massive stones were raised around 2500 BC. The druids, on the other hand, were priests of the Celtic peoples who don't show up in history until more than 1,000 years later, already in the Iron Age. In other words, by the time the druids set foot on those islands, Stonehenge was already an ancient monument, older to them than the pyramids are to us today. They didn't design it, they didn't build it, they didn't even exist when those stones were raised. The link between druids and Stonehenge was invented by curious antiquarians just a few centuries ago, and it caught on so strongly that it stuck for good. Who really built it remains a fascinating mystery. The only sure thing is that it wasn't the druids. They showed up thousands of years late to the party. You open the map on your phone, it places you at the exact corner, and you never think twice about why. Here comes the bombshell. That little blue dot works thanks to Einstein's theory of relativity, the same one that sounds like something only physicists with messy hair care about. GPS satellites orbit far from the Earth, where gravity pulls less and where they travel at high speed. Because of relativity, their atomic clocks run at a slightly different pace than clocks down here, gaining about 38 microseconds a day. That sounds like nothing, but if it weren't corrected for, your location would drift by about 6 miles every day. It would send you to a different neighborhood within hours. Engineers adjust the satellite's clocks using Einstein's formulas so the map pins you exactly where you really are. So every time your GPS saves you, thank the old guy with the wild hair. The most abstract physics is what gets you home. You picture it as one continuous line, a perfect, unbroken stone dragon from end to end. Incomplete. The Great Wall isn't a single wall, but a bunch of different walls, built by different dynasties over more than 2,000 years, with sections that start and stop, overlap, cross over each other, and sometimes run in parallel. Adding up all the pieces, including the ruined ones, it's estimated there are more than 13,000 miles of walls. But it was never one neat, unbroken line, rather a giant puzzle of fortifications built with different materials. Packed earth, stone, brick, depending on the area and the era. Large sections of the oldest parts are in ruins today or have vanished completely. In other words, talking about the wall in the singular is like talking about the highway, to refer to every highway in a country. The Great Wall isn't one structure. It's the sum of a whole lot of separate structures. You assume an hour always measured the same, a fixed 60 minutes since the beginning of time. False. The Romans divided the day from sunrise to sunset into 12 equal hours no matter what. The catch is that in summer, the day is longer and in winter it's shorter, so their hours stretched and shrank along with the seasons. A Roman summer hour could last the equivalent of about 75 of our minutes. And a winter one could drop to about 45. Nighttime worked the same way, with its own 12 hours that grew longer as the day shrank. In other words, the 6th hour of noon always fell at midday. But it didn't measure the same in January as it did in July. Only with precise mechanical clocks did the hour become the rigid block you know today. Before that, time was made of rubber. It stretched in summer and shrank in winter. You were taught that diamond is the hardest thing in the universe, period, unbeatable. Only half true. It's true that among common natural minerals, diamond is the star of hardness. Number 10 on the scale used to measure that. But the hardest thing that exists is too big a claim. There are materials that rival it or beat it. Lonsdaleite, a type of diamond with a hexagonal structure that forms during meteorite impacts, would be even tougher under certain conditions. And compounds like boron nitride in its wurtzite form show up in simulations as even harder against certain kinds of force, although that's still debated and needs confirming in the lab with pure samples. On top of that, scientists keep manufacturing increasingly extreme materials. So diamond is extremely hard, yes, but it's not the absolute undisputed king it was sold to you as. It's the champion of one category, not of all of them. They crowned something invincible that actually has serious rivals. You assume magnetic north has always been up top and south, always at the bottom, fixed for all eternity. False. The Earth's magnetic field flips every once in a while. Magnetic north ends up where south used to be, and vice versa. It's not theory. It's recorded in the rocks at the bottom of the ocean, which as they form, lock in the magnetic orientation of that moment like a frozen record. By reading those rocks, scientists discovered that the planet has flipped magnetically many times throughout its history. The last complete reversal happened about 780,000 years ago. On average, it happens every couple 100,000 years, though it's not an exact clock. Sometimes it takes longer, sometimes less. It's not an instant catastrophe. It's a slow process that takes thousands of years. But it's real. If you lived long enough, one day your compass would point exactly the opposite direction, and it would be completely normal. Don't run off on me, because halfway through the video, at lie number 33, we're going to grab one of the most famous words in science and discover it means exactly the opposite of what actually happens in reality. It's going to stick in your head. You assume ancient stuff was crude and that our modern cement is infinitely better. Backwards in a lot of cases. The concrete the Romans used was so good that buildings almost 2,000 years old are still standing, while modern cement often cracks within decades. The Dome of the Pantheon in Rome is still today the largest unreinforced concrete dome in the world, and it's about 1,900 years old. Recent studies uncovered the secret. The Roman mix contained little lime clumps that, when a crack appears and water seeps in, react and reseal the fissure on their own, like a wound healing itself. In other words, the material repaired itself. Engineers today are trying to copy that recipe, which had been lost. So next time you think ancient people were just a bunch of brutes with rocks, remember? They invented a concrete that heals itself, something we're only now starting to understand again. You're sure the Earth has just one moon, period, the usual one? Incomplete. Our big moon is the only permanent one. But every once in a while, the Earth captures small asteroids that end up orbiting us for a while, like temporary little moons. Astronomers call them mini-moons. They're tiny rocks, sometimes about the size of a car, that pass close by, get caught by Earth's gravity for a few months or a few years, and then escape back out into space, continuing on their way. Several have been detected, with catalog names like the object that hung around between 2018 and 2020, and others that showed up more recently. They're so small and faint that you need a telescope to see them, so they go completely unnoticed by the naked eye, but they're out there, keeping us company from time to time. The Earth doesn't always travel with just one companion. Sometimes it has a second, secret little moon orbiting quietly, without you ever finding out. You picture Columbus stepping off his ship and planting the flag in North America. A lie. Across his 4 voyages, Christopher Columbus traveled through the islands of the Caribbean, like the Bahamas and Hispaniola, and only on later voyages did he reach the coasts of what is now Central America and the north of South America. But he never not once set foot on the territory of what is now the United States. He died convinced, on top of that he had reached Asia, the Indies, without realizing he had stumbled onto an entire continent unknown to Europeans. And centuries before him, the Vikings had already reached the northern part of the continent. So the man who gets a holiday dedicated to discovering America didn't even set foot on most of it. And he died believing he was somewhere else in the world entirely. Columbus's geography was, let's say, a work in progress. You watch fireworks and think the colors are pure visual invention, pyrotechnician magic. False. Every color in those bursts is a different chemical element. Almost always a metal salt, showing off its signature. The intense red comes from strontium. The bright green comes from barium. The blue, which is the hardest one to pull off, comes from copper. The yellow is painted by sodium, the same element in table salt. And the oranges usually come from calcium. Each metal, when heated, gives off light of a specific color, as if each one had its own personal, non-transferable shade. Pyrotechnicians are, deep down, chemists who mix these ingredients to paint the sky. When you see a green firework, you're seeing barium showing off its color. When you see red, that's strontium. The sky at a celebration isn't magic. It's the periodic table putting on a show for everyone. You take it for granted that a day has always been 24 hours, from the dinosaurs to today. A lie. The Earth is slowing its rotation little by little, because the moon pulls on its tides and steals some of its momentum, like a hand slowing down a merry-go-round. The result is that days get longer by about 2 milliseconds per century. Sounds like nothing, but added up over geological time, it's massive. Back in the age of the dinosaurs, a day lasted around 23 hours. And 600 million years ago, it was barely 22. The moon, meanwhile, drifts away from us by about 1.5 inches a year, roughly the rate your fingernail grows. That's why every once in a while, atomic clocks add an extra second so they don't fall out of sync. The day isn't some eternal constant. It's a number that grows at a snail's pace, and you're living longer days than any dinosaur ever did. You were taught that Copernicus was the first human to realize the Earth orbits the Sun. False. Almost 1800 years before him, a Greek astronomer named Aristarchus of Samos had already proposed that the Sun sat at the center, and that the Earth revolved around it, back in the 3rd century BC. The idea existed, it was written down, but it didn't catch on. Because in his time, the dominant view was that the Earth sat at the center of everything, and that belief held for centuries. Copernicus, in the 16th century, picked the model back up and developed it with more solid math, putting it back on the table. And this time, it really did change history. His enormous achievement was rescuing and better proving the idea, not inventing it from scratch. The sun at the center wasn't a Renaissance brainstorm. Greek had already thought of it almost 2,000 years earlier, and the world had sent it into oblivion. You see a colorful glowing sign and naturally call it a neon sign. Almost a lie. Neon, the gas, only produces one color, an intense reddish orange. That's the only shade pure neon gives off. Every other color you see in those signs comes from other gases or other tricks. Argon mixed with a little bit of mercury gives blue. Other noble gases give other shades, and to get more variety, the tubes are coated on the inside with phosphor coatings that change the color of the light. In other words, a neon sign that's green. Pink or white doesn't have neon making that color. It's a different combination of gases and coatings. The name stuck because neon was one of the first ones used and became the generic brand name for all of them. So the next time you see a sign with 1,000 colors, now you know. In most cases, all it has of neon is the name. You say steel, like it's just another metal, pulled straight out of nature. False. Steel doesn't exist in pure form in any deposit, because it's not an element, it's an alloy, a mixture made by human beings. It's made by combining iron with a pinch of carbon. generally less than 2%. That sounds like almost nothing, but that tiny touch of carbon is what transforms iron, which on its own is softer and rusts easily, into a material that's much harder, tougher, and more useful. By changing the amount of carbon and adding other elements, you get different types of steel for different purposes, more flexible, harder, stainless. In other words, steel is a recipe, not an ingredient. It's more like a cake than like flour. Humanity took centuries to master that exact mixture, and once it did, it changed construction, tools, and machines forever. You don't dig steel out of a mine, you cook it yourself. You were told that as the year 1000 approached, all of humanity fell into panic, waiting for the ends of the world, trembling with collective terror. Almost a lie. That image of terrified crowds counting down the days is, in large part, an exaggeration invented much later, mostly by writers from later centuries who romanticize the era. The reality is that most people back then didn't even have a clear idea of what year they were living in. The system of counting years from the birth of Christ wasn't yet widespread or in everyday use for the average peasant, who went by harvests and seasons, not a calendar number. There were no clocks, no newspapers, no global awareness of the date. So that supposed massive, synchronized terror over the year 1000 is more of a later tale than a historical fact. People in the Middle Ages had plenty of real worries. A round number on the calendar wasn't one of them. You were told that Isaac Newton invented mathematical calculus all on his own, like some isolated genius who thought it all up. Incomplete. At the same time, in Germany, a guy named Gottfried Leibniz developed calculus on his own, independently, without copying anyone. The two of them arrived at the same fundamental ideas almost in parallel in the final decades of the 17th century, and that sparked one of the most famous feuds in the history of science, with accusations of theft flying both ways for years. The irony is that the notation you use today in class, those symbols with the D and the elongated integral sign, are Leibniz's, not Newton's, because they turned out to be more practical and stuck around. So calculus had two fathers who couldn't stand each other, each one convinced he'd gotten there first. History gave nearly all the credit to one of them, but the truth is, it was two minds working at the same time. The lone genius was actually a feuding duo. The word atom comes from Greek and literally means that which cannot be cut, or indivisible. The ancients named it that, believing it was the smallest possible particle, the final building block of everything, impossible to split, completely backwards. The atom does split, and in several ways. Inside it has a nucleus with protons and neutrons, and electrons spinning around it. So right off the bat, it already has parts. And those parts split even further, because protons and neutrons are made of even smaller pieces called quarks. On top of that, nuclear energy comes precisely from splitting atomic nuclei, something the Greeks would have sworn was impossible. In other words, they named the thing that can't be cut, one of the things we've learned to cut the most. The name stuck in science out of habit, even though it means exactly the opposite of reality. The atom isn't the end of the road. It's just a door into a world that's even smaller and stranger. You think it took satellites and modern technology to find out how big the Earth is. Backwards. A guy did it with two sticks and a brilliant mind more than 2,000 years ago. Eratosthenes, a Greek scholar living in Egypt around the year 240 BC, heard that in one city, at noon on a certain day, the sun fell so directly overhead that it cast no shadow inside a well. In another city farther north, that same day and hour, a stick planted in the ground did cast a shadow. By measuring the angle of that shadow and knowing the distance between the two cities, he used pure geometry to calculate the circumference of the planet. He landed on a number astonishingly close to the real one, all with the two sticks and a brilliant mind. No ships, no photos, nothing. Just sticks, shadows, and math. The Earth had been measured with stunning accuracy thousands of years before a single satellite ever existed. You think magnetic north is nailed down at one fixed spot, sitting still, always waiting for you in the same place. False. The Earth's magnetic north pole moves, and lately it's been moving fast. During the 20th century, it wandered slowly around northern Canada. But in recent decades, it's sped up and is now drifting towards Siberia in Russia at a speed of tens of miles a year. That shift is so significant that in 2019, scientists had to update the global magnetic model ahead of schedule. The model used by navigation systems on planes, ships, and even the map on your phone. If they hadn't corrected it, the compasses in those systems would have started drifting further and further off. In other words, that point you think is fixed is actually a wanderer that's currently on its way to Russia, unhurried but unstoppable. Magnetic north doesn't have a permanent address. It's in a constant state of moving out, and nobody fully knows where it's going to end up. You assume that when someone discovers something brilliant, the world applauds right away. A lie. Gregor Mendel, a monk who grew peas in a monastery garden, discovered the basic laws of heredity, how traits pass from parents to children, and published his results in 1866, and absolutely nothing happened. His work sat buried, ignored, gathering dust, because almost nobody understood the importance of what a monk counting plants had found. Mendel died without ever knowing he had founded an entire science. Only around 1900, more than 3 decades later, did several researchers separately rediscover his ideas and realize that this forgotten monk had solved the puzzle of heredity long before anyone else. Only then was he crowned the father of genetics. One of the most important discoveries in all of biology sat shelved for 35 years. Sometimes the world takes an entire generation to notice what was right in front of it. You've heard Bronze Age 1,000 times and figured bronze was a metal just pulled straight out of the ground. Incomplete. Bronze doesn't exist in nature. It's another alloy, a mixture of copper and tin, generally with a lot more copper than tin. And that's where it gets interesting. Copper was relatively easy to find in a lot of places, but tin was scarce and found in only a few spots in the ancient world. To make bronze then, you absolutely had to get your hands on tin. And that forced peoples to set up incredibly long trade routes, moving the metal across seas and mountains. In other words, that mixture didn't just produce tools and weapons far better than stone ones, it also drove long-distance trade and connected civilizations that were extremely far apart. The Bronze Age wasn't just about a harder metal. It was an era where the search for a scarce ingredient ended up weaving together the world's first great trade networks. You look at photos of astronauts floating and figure there's a ceiling and a floor, and up and a down just like in your bedroom. A lie. In space, no direction is privileged over any other. Up and down are ideas that only make sense here. On the surface of a planet, where gravity pulls you toward the center, and that gives you a very clear down, the ground, and an up, the sky. But an astronaut floating in orbit has no real down at all. They can orient themselves any way they like, and for them, it's all equally valid. Space stations are designed with a fake up and down, painted and arranged, pure convention, so the human mind doesn't get dizzy and knows where to put its feet. In the universe, in the vacuum, there's no cosmic arrow pointing this way is up. Up and down aren't truths of the cosmos. They're inventions that come from living stuck to a planet that always pulls you the same direction. And to close things out, the most beautiful one of all, you think the atoms in your body were manufactured right here on Earth, like it's nothing special, backwards and in a beautiful way. Almost every element that makes you up, the carbon in your skin, the oxygen you breathe, the calcium in your bones, the iron in your blood, was cooked inside the hearts of giant stars billions of years ago. Stars are nuclear factories that build increasingly heavy elements inside themselves. And when some of those stars explode at the end of their lives, they scatter all that material across space. Our solar system, the Earth, and eventually you, were built from that cloud of stellar remains. In other words, it's not cheap poetry, it's proven physics. Every atom in you, except for the simplest hydrogen, once passed through the interior of a star. You're not just made of earthly clay. You're made of the remains of ancient stars, walking and breathing around. And with that, 40 lies torn down in one shot. If this blew your mind, drop a like, subscribe, And tell me in the comments which one was hardest for you to let go of, because in the next video we keep on busting myths.